Rules of differentiation with economic applications. So this is again a very basic video. I'll be talking about certain basic rules of differentiation. I'll give you a few examples from economics also while doing this. So, and for next 3 or 4 classes, I'll be doing it just the screen recording. I'm not feeling well since last 2 or 3 days. Anyways, rule 1 beta. Derivative of a constant function fx equals to c. So if you have a constant function like this, then its derivative is 0. So let us say you have the TR function, total revenue function of the competitive firm. So total revenue is how much revenue you are making. So you are selling Q units at price of P. So the total revenue which is being generated is P into Q. And for the competitive firm, the prices are given to you. So price is constant. Vidhi is also making one very good series on basic maths. So she'll be talking in detail about these derivatives, integrals, and all. So I'm just doing that much which is required for the micro course. I'm doing just that much of maths which is required for the micro course. She will dig deeper into the mathematical parts. So TR is P bar into Q. Well, you have the revenue and you have Q out here since. So as Q is increasing and P is given to you, so this is just this function. What about the marginal revenue function? So in case if you are selling one more unit of the output, how much change in revenue is coming through that? That is the marginal revenue function. So MR is dTR by dQ. So you just differentiate this guy and you'll be getting just P bar. Right. And you try to plot it. This is going to be your MR function. And as you guys could see that this MR function is a constant function. So dMR by dQ, that is 0. dMR by dQ, that is 0. So that was the first rule. Second rule. Rule 2. Derivative of a linear function. So you have fx equals to mx plus b. M and B are constants. M and B, they are constant. So if you have then F dash X is equal to M. So if you just write the slope of a linear demand function. So you have Q equals to 30 minus 2P. This is the demand function. This is the function of prices and quantity. This is telling you that as price is going to increase, you'll be demanding less of the quantity. 2P equals to 30 minus Q. P equals to 15 minus half of Q. Now, if I just want to draw this, well, this is a linear function. So if Q is 0, P is 15. And if P is 0, Q is 30. If P is 0, Q is 30. Right. You can find out the slope of this line. I've told you in the earlier class of the budget line also, where we talked about that you have the slope is the intercept on the y-axis upon the intercept on the x-axis, which is 15 upon 30, which is equal to half. Otherwise, you can also write dp by dq equals to minus half. dp by dq is equal to minus half. Then rule 3. Derivative of a power function fx equals to x to the power n. So if fx is equal to x to the power n, then f dash x is n x to the power n minus 1. Right. So supposedly, if you have the say y is equal to L to the power alpha, is the production function. Is the production function, right? With alpha greater than 0. So this production function is nothing but the total product, right? TP, how much you are able to produce using labor. Marginal product is if you employ one more unit of labor, how much is the total product going to change? The change in total product due to the employment of one more unit of labor. Right? And how will marginal product change? So this is the marginal product function, alpha into L to the power alpha minus 1. How will marginal product change when you have one more unit of labor? Alpha into alpha minus 1 into L to the power alpha minus 1 minus 1, which is alpha minus. So it depends on whether alpha is greater than 1 or alpha is greater than, if alpha is less than 1, that is going to determine the sign for the change in the marginal product function, right? Another rule, beta, rule 4. Derivative of a constant multiple of a function, right? So if you have the function gx, which is c into fx, and g dash x is c f dash x. So say c is a constant, right? Say you have the function gl as 5l squared. So I can write L square as the function also. So this GL will become what? 5 into the another function. So G dash L is what? 5 into F dash L. And what is F dash L? That would mean what? 10L. Rule 5. Derivative of sum or difference of a pair of function. If you have the function hx, which is the sum of two functions, then h dash x will also be the sum of the derivative of the two functions, right? If you have the function hx, which is the difference of two functions, then the derivative of this h dash x is the difference of the derivative of the two functions. So hx is 4x plus x squared. So that is the sum of the two functions. H dash x is sum of the derivative of 4x, which is 4, plus the derivative of 6x squared, which is 12x. Rule 6. Derivative of the product of two functions. So if hx equals to fx into gx. Then h dash x is first function as it is into derivative of second function plus second function as it is into derivative of the first function. So say hx is equal to 2x plus 5, 3x squared plus 2x. So these are the two functions, and hx is the product of these two functions. So h dash x is first function as it is into the derivative of the second function, which in this case is going to be 6x plus 2 plus second function as it is into the derivative of the first function, which in this case is coming out to be 2. So I'm not solving it further. You guys can do that yourself. So supposedly if you have say, there's nothing say about it. TR function is like this only. P into Q. And P is dependent upon Q. So P is the function of Q itself. Right. And dTR by dQ. First function as it is into derivative of second with respect to Q is 1. Plus second function as it is into derivative of PQ with respect to Q, that is dPQ by dQ. Right? So I can very well write this as P plus Q into, and this guy is nothing but P dash Q. This is what my MR function is, marginal revenue function. Right? Correct? I think it forgot to draw a rectangle. So supposedly you have the demand function. (40 minus TQ). So if I need to find out the TR function, it's going to be price into quantity. Price is what? 40 minus TQ into Q. Price is what? 40 minus TQ. TR is what? 40 minus TQ into Q. So this guy is the first function. This is the second function. So if I want to write what is MRQ, this is the product of two functions. So first function as it is into derivative of Q with respect to Q is 1 plus second function as it is into derivative of first function with respect to Q is minus 2. So once you open this up, you'll be getting 40 minus 2Q minus 2Q. So that is 40 minus 4Q. Derivative of derivative of the quotient of two functions. So you have seen the product of the two functions. Let's look at the quotient of two functions. So if hx equals to fx by gx, and gx is not equal to 0. So how do you write this? What is the derivative of this function h dash x? Derivative of the numerator into denominator as it is minus derivative of denominator into numerator as it is whole upon denominator square. Say hx equals to 2x plus 5, 3x minus 2. So h dash x is derivative of numerator. So derivative of numerator is derivative of 2x plus 5. What is that? 2. Derivative of 2x plus 5 with respect to x is 2 into denominator as it is minus derivative of denominator. Derivative of 3x minus 2 with respect to x is what? 3 into numerator as it is. You can also use as an example for the quotient rule, the relation between the average and the marginal value of the function. Ax is fx upon x. So for a dash x, what will you write? Derivative of numerator. So ax is the average value of the function. So when you write the average value of the function, that is function upon x. So for example, you have any function. For example, the total cost function. Total cost function is TC. Average cost function would be TC upon Q. That is the average cost function. So here the average function is fx upon x. So if I take up the derivative of the average function, this will be a dash x is f dash x derivative of numerator into derivative of numerator into denominator as it is minus numerator as it is into derivative of denominator with respect to x. So derivative of x with respect to x is 1. Next square like this. So I can write this as f dash x upon x minus fx upon x square. I can write like this. I can take up this 1 upon x common. Beta, what is f dash x? F dash x is the marginal value of the function. Huh? Marginal value of the function. What is fx upon x? That is the average value of the function. No? Hmm? So this is the relationship between the average value and the marginal value of the function. Hmm? That is there. Then rule number 9. Derivative of a function of a function. Derivative of a function of a function. If y is equal to f of u and u is gx. So, of course, y is the function of x. How? Like this. Let's say I call this as hx. So h dash x would be what? F dash u into g dash x. So, or you can also write it like this, dy by dx. So, dy by dx. So, first of all, you differentiate this, dy by du, and then you differentiate this, du by dx, right? So, say y is equal to 2x square plus 3x plus 10. So I can write, say, u is equal to 2x square plus 3x. So y is equal to nothing but u to the power 10, and u is nothing but 2x square plus 3x. No? So dy by dx is dy by du into du by dx. So dy by du is 10 into u to the power 9. And derivative of u with respect to x is what? 4x plus 3. So you can also write it properly. N into 2x square plus 3x to the power 9 into 4x plus 3. into 4x plus 3. That's an idea. Then rule 10. Derivative of inverse of a function. So if you have y is equal to fx, if y equals to fx has the inverse function. X equals to gy. Then dx by dy is nothing but 1 upon dy by dx. Is nothing but 1 upon dy by dx. Or you can say g dash y is equal to 1 upon f dash x. Rule 11. Derivative of exponential function. If you have y is equal to ex, then dy by dx is equal to ex. Vidhi has also made a very important recording on the graphs of exponential and the logarithmic functions. So I'm again and again putting this thought in your head that I am only doing that much of maths which is required in the micro course and maybe somewhat in macro course. But she is making those videos which are helpful for a deeper understanding of maths. So you can watch those videos also. So suppose the price of the product increases exponentially. Let's say the price of the product increases exponentially. So the price of the product increases exponentially, right? And say G is the rate of growth. In the price. And let's say we are looking at the growth for T years in between. So whenever you look at the growth, let's say you're looking at the growth for 10 years, 20 years, and something like that. So T years, right? P naught is the price of the product when the good is sold, right? So naturally, your since um, this price is the exponential function, right? So price of the product is the exponential function. So I should rather write your P naught is the initial price of the product. Price of the product initially. Then only we'll be able to find out the growth. Huh? So let us say you have PT equals to e to the power gt P naught. So you start with the initial price P naught, and then this price is increasing. And note that this price is the function of T. Price is the function of T. And this is increasing exponentially. So definitely your E has to be, E to the power T should be there. And this is increasing with the growth rate G. So if I want to find out what is dP by dt, so that will be what? P naught is a constant into derivative of e to the power gt. So e to the power gt's derivative is e to the power gt into derivative of gt with respect to t. So that is just g. So this dpt by dt this is the rate which price changes per period. And one thing I'm just telling you, you can keep this in your head. So just something extra. If I need to find out the proportional growth rate in P, say proportional growth rate or the percentage growth in P. So so what is dpt by dt beta? You have already found out, which is P naught into e to the power gt into g. And what is pt? Pt you know, which is P naught into e to the power gt. So this P naught will get cancelled out. E to the power gt, e to the power gt will get cancelled out. Will be left off with only g. So g is the growth rate in P. So g is indeed the growth rate in P. So these exponential functions are used for the growth rates. Then Rule 12. Mm. Derivative of the logarithmic function. So if you have the function like this, y equals to log x. So dy by dx is 1 upon x. This is your derivative of the logarithmic function. Chain rule can be applied here as well. So if y equals to log of gx, like this. So now y is not directly dependent upon x, but y is the logarithmic function of the function. So I can say gx is equal to u. So y is equal to log u is equal to gx. So dy by dx is dy by du into du by dx. Dy by du is 1 upon u into du by dx is g dash x. So 1 upon gx into g dash x. So this is the way you write it. This is the way you write it. This will be very useful in finding out the elasticities. This will be very useful in finding out the elasticities. So, acha, when I say elasticity, it means what is the proportional change in demand due to the proportional change in price. So in case if price changes by 1%, what is the percentage change in demand? That is what elasticity of demand or price elasticity of demand is. Let me just write that for you. Percentage change in demand upon percentage change in price. So if price changes by 1%, what is the percentage change in demand? Right, that's what the uh, elasticity of demand is. So say for example, y is equal to alpha into p to the power minus beta, right? Into p to the power minus beta, like this. So what I can do is, I need to find out what is the price elasticity of demand for this. percentage change in demand upon the percentage change in price. You remember when we found out this, we have done nothing but we have sort of calculated the percentage change here. Right? We have calculated the percentage change here. So we can calculate the percentage change here as well. We can do that. Right? We can find out the percentage change here as well. So how do we find this out? We can take up the log of both the sides. So it is going to be log of like this. So log of A into B is log of A plus B. And log of B to the power C is C log B. Right? We can do it this way. We can do it this way. Okay. So can we just write it in this way? Log of Y equals to log of alpha minus beta log B. Fair enough. So can I write this as Y hat? This is, let's say, alpha hat. So these are the transformed variables. Beta is beta only. This is P hat. This is P. So if I find out dy hat upon dp hat is nothing but minus beta. This is nothing but minus beta, right? So, and what is this dy hat upon dp hat? Dy hat is what? D log of y upon d log of p. This is what elasticity is. This is what elasticity is. Now, you must be thinking, I mean, what is this? So, can I write this elasticity of demand as this? Just wait. Percentage change in demand. So, percentage change in demand is like this. Delta Q upon Q. That is the percentage change in demand. ऐसे निकालते हैं ना? You find out percentage change in anything. How do you do this? So, for example, in time period 1, the value of the function is Q naught, let's say. In time period 0, it was Q naught. In time period 1, it is Q1. So the difference between them is Q1 minus Q naught. And you divide it by the base, which is Q naught, into 100. That is what the percentage change in demand. Na? This is the way you find out. Beta, this is the way you find out. Similarly, the percentage change in price could be written as this. Right? So this 100 will get cancelled out. Yes. Delta Q by Q into P by delta P. So what is this, beta? Delta Q by delta P into P by Q. So you started with this elasticity definition. The only thing is that you have to understand this guy. How do you find out the percentage change in anything? So initial value of the function is Q naught. The new value of the function is, you find out GDP in year 2020 is X naught. GDP in year 2021 is X1. So what is the percentage change? GDP in year 2021 minus GDP in year 2020, that is the change in GDP, upon GDP in year 2020 into 100 will be giving you the percentage change. So the same thing. Beta, this del Q by del P, it could be written as dQ by dP. So whether you write dQ by dP or dy by dx, that is nothing. There is no problem. So this is what it is. dQ by dP into this guy. So you have what? Elasticity of demand is dy by dP into P by Q. We have written like this. Okay. Achha, now in for this function only, let me just find out elasticity normally. So you have y equals to what? Alpha into p to the power minus beta. So dy by dP is what, beta? Alpha into minus beta into p to the power minus beta minus 1. Right? Okay. For elasticity, what do you need? Dy by dP into p by y. This will be y. So what is dy by dP? Minus alpha into beta into p to the power minus beta minus 1 into p upon y. Y is what? Alpha into p to the power minus beta. Okay, now you tell me. This alpha is gone? Yes. Right? Okay. How can you write this p? This is p to the power minus beta minus 1 upon into p to the power 1. So it is what? Minus beta minus 1 plus 1. Your indices are added. So this minus 1 plus 1 is cancelled. You have just p to the power minus beta upon p to the power minus beta. And you have left out with this. So this is the way you find out the elasticity. So I've shown you how do you find out the elasticity of demand and how also you find out elasticity of demand using logarithmic way. Using logarithmic way. So, achha, you think about it this way. So what is an easy way of going about this is take up the logarithm of both the sides and just write what the thing is. So what you can do is, so what we are saying is these two formulas are same for elasticity. D log y on d log x. These are same beta. No, not d log x. So what is d log y? If you differentiate d log y with dy, what will you be getting? 1 upon. So how can you write d log y? Dy upon y. That is the first thing. Similarly, if you differentiate d log p with p, what will you be getting? 1 upon p. So what is d log p? dp upon p. No? Just put it, beta. Just put it d log y upon d log p. In place of d log y, so if I just going to divide first by second, I'll be getting this. Right? I'll be getting this thing only. And since it is the price elasticity of demand, so I'm putting the minus sign. So I've just told you that these two formulas, beta, this formula and this formula. They are equivalent. They are equivalent. So I hope you like this video. And this is the another very basic video on rules of differentiation. Right? Chali. Thank you, beta.